The clinical effects of vitamin D deficiency we can look at in three ways. First, let's think about observation. And we've seen a lot of this, so I'll move through it very quickly. That generally speaking, we find that low blood levels are associated with high mortality risk. This is a particularly good study from the US, showing those with the highest levels of vitamin D in the left-hand columns, and we're looking at mortality risks for all causes in blue, cardiovascular disease in green, cancers in yellow, and infectious disease in pink. And we can see for all of these, the mortality risk increases with lower levels of vitamin D. If we look at all causes, we can see the mortality risk is 8% higher in those with the lowest levels compared to those with the highest levels. And if we look at cancer risk isolated, then we can see a 40 to 50% increase in cancer risk with those with the lowest levels of vitamin D. So to start with, we might say vitamin D and cancer. Yes, it's worthy of further investigation. These observations cannot be ignored. Now, the observations that suggest vitamin D effect are firstly direct measurements of vitamin D, such as we've seen, and those of the indirect assessment of vitamin D. Now, the indirect assessments are generally based on three factors: the seasonality of disease, the geography of disease, and the sociology of disease. We put the three together. The geography, we see more cancers in northwest UK, northwest Europe. We see more cancer problems in the winter than the summer, and disease in general. And with sociology, we can see the socio-economically disadvantaged, the poor people, come off worse as usual than the wealthy people. Put them all together, and if we have poor people in the northwest of the UK in the winter, the health profile is absolutely dreadful. The general explanation for this is something that's called victim blaming. It's their own fault for eating the wrong foods, living the wrong lifestyle, etc., etc., etc. That victim blaming is wonderful for the government. It lets the government off the hook. The government needs to take no action. What we've got to do is educate the people to look after themselves properly. Well, victim blaming is really, it's just disrespectful, it's dreadful. The real problems arise around vitamin D deficiency. And so let us look at vitamin D and season for a start. We've looked here at the graph that Rufus showed us earlier on with a seasonal variation of vitamin D, and we can see that the average is about this level, at about 20 nanograms, 22 nanograms per mil. So vitamin D is related to season. Vitamin D is related to geography. And here we see in the United Kingdom, again from Melina Huppenden's work, in the south of England, we're looking here at profound vitamin D deficiency. That's blood levels less than 10 nanograms per mil. There are not many countries where anyone has blood levels of vitamin D less than 10 nanograms per mil, but they do in the UK, and particularly in Scotland. And in the winter in Scotland, we can see that the frequency of vitamin D profound deficiency is twice that in the south of England, and also in the winter time. Very serious problem. And we've looked at this, Oliver showed us this curve earlier on. We're looking at the sunshine distribution of the UK. Not much sun in the northwest of Scotland, but I do recommend it to you as probably the most beautiful part of the world. We've got latitude effect, yes. The further north we go, the greater the inclination of the sun, the greater the distance the sun rays have to travel through the atmosphere, and the less energy reaches ground level. Vitamin D and socioeconomic status. There's something here. The lowest levels of vitamin D are found in the disadvantaged. Again, Alina Hippenham's work. And we can see as we go down the social scale, as it were, we can see in the winter and spring and in the summer and the autumn, we can see that the blood levels of vitamin D go down during that time. The unemployed, the long-term unemployed, have by far the worst health profile of anyone in this country, and they have the lowest vitamin D levels. And the profound efficiency, also once again, we see it in the unemployed. You might think the unemployed have plenty of time to sit out in the sun, but I'm afraid that is not the life pattern of the long-term unemployed in this country. So back to cancer, the geography of cancer. We've seen a lot of this already a few moments ago from Bill. I won't go into it in too much detail, but we've already also heard mentioned Appler's work of 1941, when he divided North America into 4 latitude zones and looked at cancer mortality in each of those, starting in Mexico and moving into Canada. And as he went from Mexico on the left to Canada on the right, there was a stepwise increase in mortality. Now, this gradual stepwise increase is actually very important. Cancer survival is better in the south of England than the north. And we can look at cancer survival for all cancers here for the various parts of the regions of the United Kingdom. As usual, we get the Thames regions and Oxford near the top. We get Yorkshire, the northwest and the north near the bottom with the worst survival, 5-year survival rates. Stomach cancer alone, we're comparing now northwest Thames with the northwestern England. So northwestern England in pink, northwest Thames in blue. We can see firstly survival from stomach cancer is not good. It's not a good cancer to have. But we can see that it's better if you happen to be in the northwest Thames than if you happen to be 200 miles further north in the northwest of England. Colon cancer survival rates in this country. The yellow pointer looks to the England average, and better than average, no surprise, southwest, east of England, southeast and London. And worse than average, no surprise, Yorkshire and Humber, West Midlands, East Midlands and Northwest. This is a pattern all the time that we see. It's a consistent pattern. The risk of developing carcinoma, adenocarcinoma of esophagus. If we standardise at 1 for Scotland, we can see about 3/4 of that in England, gradually reducing to less than half in the Netherlands, France and the USA. Once again, the same consistent pattern, which I believe cannot be ignored. Breast and colon cancer deaths in Europe. Greece, Spain, Italy at the top, no surprise. Northern Ireland, Republic of Ireland, England and Wales at the bottom. Again, no surprise. Consistent difference. Big differences in mortality rate, twofold or more than twofold. And if we put a regression analysis on that, we're going to see a very powerful regression for both breast and colon, with R squared very close to 1. A powerful effect of latitude on death rate from cancers of the breast and colon. Colon cancer survival is better in mainland Europe, in the southern parts, than in the northern parts of Europe. Again, the average is the yellow pointer, and we can see that Spain, Italy are doing better, and we have the Thames, Mersey doing badly, and also Krakow in Poland. The best of all is Modena in northern Italy. And you might say, well, it was put in the paper that Modena probably has the best health facilities in Europe. That requires demonstration. But I went to Modena about 6 months ago. I thought, I've got to go and see this place that's doing so well. And it's a very, very pleasant town. It's built around concentric streets around the city square. It's famous for Maserati and Ferrari cars, but it's particularly famous for the balsamic vinegar, which you'll notice most of it comes from Modena. But one thing I noted about the place was the people standing around, and these men standing talking. And here they are, they're not sunbathing, they're just getting incidental sun exposure. They're not standing in the shade, they're standing in the sun. And they look pretty elderly, and they're enjoying a good old age, I think supported by plenty of sun exposure and vitamin D. This is a scene that you would not see, really, in the United Kingdom, and certainly not in the northwestern parts of the United Kingdom, when people are rushing indoors to shelter from the rain. Cancer survival. is better in Europe and the USA. By that I mean mainland Europe, because of course the UK is part of Europe, which we must always remember politically. And here is another consistent pattern: cancer of lung, prostate, breast and colon. And we can see the survival figures are better. They're at the worst in England, Wales and Scotland throughout, and they're at the best in mainland Europe and the USA. The consistency of this cannot be ignored. Now, our MPs are very worried about this. They feel that our survival rates are still behind the best in Europe. Our football teams might not be, which is perhaps more important, but cancer survival rates are really not good. And they're a political embarrassment, because health is a major function of the government in the UK, where we have a nationalised, effectively, health service. So the implication is that our medical facilities and expertise are not very good, and that the answer is money. And a great deal of money has been put into health facilities over the past decade, and in particular into cancer treatment and etc. But are we really short of medical expertise? Some will think we are, and some will think we are short of facilities. Are we short of money? Well, we always say that we are, whether we are or not. But perhaps the answer lies in geography and vitamin D, rather than a lot more money. Let's compare for a moment. Let's think about Glasgow and Belfast. 55 degrees north of the equator, the same latitude as the southern parts of Hudson Bay, southern parts of Alaska, Siberia, further north than anywhere in China. The health profile in Glasgow and Belfast is dreadful. Let's compare Belfast to Toulouse in the south of France, just about 1,000 kilometres further south. And we can see cancer rates, and we're looking at two groups of men, 45, 54 and 55, 64. And we can find a 20–30% increase in cancer deaths in these relatively young men. Well, they're all younger than me anyway. But this is geography. And the point is, it's not just cancer. There's something more general about it. And if we look at coronary heart disease in the younger group of men, 4.2 to 1 ratio. All-cause mortality, 1.4, 40% increased mortality in the younger men, and 8% increased mortality in the slightly older group of men in Belfast and Toulouse. Very, very big differences. Explanation? Well, in the various studies, there was none given. This is part of the Monica project, well-funded, very, very detailed research. The conclusion was, we don't know the answer. Well, I've spoken to the main author of this study, and he said, well, we did think of vitamin D in the sun, but well, they didn't measure vitamin D. They measured everything you can imagine except vitamin D, and there was no explanation. But I believe that it is vitamin D, is the fact that it protects against illness. Cancer. Let's look for a moment at social groups. Again, this is a UK study. The survival from cancer is worse in the disadvantaged. It's the poor that get the blame, I'm afraid. If they're disadvantaged in one way, they're disadvantaged in everything else. And here we can see cancer survivals in this country related to social group. Again, less than 50% survival in this study in all. And the blue top line is the affluent, and the bottom line is the deprived, the poor. So no one does particularly well, but the wealthy do better than the poor. And once again, there's a gradient between the two, which is very important. Malignant melanoma outcome. Some studies from a few years ago, and we can see that the survival, relative survival, 5-year survival, is better in the affluent than in the deprived. The affluent had lost a lot of the advantage by 1990 compared to the early part of the study. And we've already seen the work from Julian Newton-Bishop in Leeds that 6-year relapse-free survival is related to vitamin D levels. The higher the vitamin D, the better the survival. This one I find extremely interesting, and this is incidence of lung cancer in smokers by social class. And I think this study came from Denmark. So we have three groups of people: the low social class, as it were, the poor, the medium, and the high, like ourselves, the high social class. We can see after more than 15 years of follow-up, about 7% or thereabouts of the poor had developed lung cancer, compared to less than 2% of the wealthy. So if you're going to smoke, it's better to be wealthy, basically. And once again, there was a gradient between the two. Poor people don't smoke. Let's look at something else about lung cancer: cancer and season. The outcome of lung cancer, this is a single study, but an important one, is better when diagnosed and treated in the summer. And here we have it. January and February, we can see, and November, December, we can see a worse 5-year survival rate than when the diagnosis and treatment were in the summer. Let's add something else, not just season, but also vitamin D. And let's look at people who were diagnosed in the winter and did not take vitamin D supplements. Well, they did dreadfully badly, compared, of course, to those who took vitamin D supplements and were diagnosed in the summer, where the survival is more than twice as good. This is really very, very important again. Now, how this has been translated into standard clinical practice, I've no idea, but I very much doubt if it has. We can't choose the time of the year we're diagnosed, but we can choose whether or not we take vitamin D supplements. Prostate cancer, well, I'll run through this quickly because Bill's already spoken about it. Again, age at diagnosis. The point is, by the time we get to 90, we men have all got prostate cancer, but I'll come back to that in a moment. But the age of diagnosis is pushed forward in people with the lowest levels of vitamin D, those in the dotted line. The incidence is lowest with the highest ultraviolet exposure. And again, as we go from 1 to 4, we're increasing ultraviolet light exposure by history taking, and we're seeing a lower level of prostate cancer. Colon cancer, related to vitamin D intake. Again, the highest intake, column 5, has the lowest incidence of colon cancer. Ethnicity is an important thing as well as a measure of vitamin D, as we've heard. Colorectal cancer. In the United States, in the black population, twice the incidence of colon cancer. In the UK, the incidence in the South Asian population is increasing fairly rapidly and is about to exceed national average. We're looking at evidence. And I find, I must say, and I'm sure you all do, otherwise you wouldn't be here, that the evidence is pretty compelling. People ask for proof, often not knowing what proof is. And what we really need is judgment. Now, proof was defined by the Greek mathematician, philosopher Euclid as quod erat demonstrandum, meaning what was to be proved. In other words, it's the fulfillment of predetermined criteria. And that is the basis of the randomized controlled trial. Now, if we're going to do a trial of vitamin D, perhaps we must optimize the blood levels of vitamin D in individuals before they actually enter into the trial. Now, this is going to take an awful long time, an awful lot of money, and I'm not sure, as someone said this morning, if it's going to happen in our lifetimes. But what do we do in the meantime? What are we doing while we're waiting for the randomized controlled trials? Proof is pragmatic, it's not absolute, and judgment is also even more pragmatic. What we have to do is make decisions as individuals, and then of course is public policy. Now, what do I do as an individual on the basis of the evidence? Do I take vitamin D supplement? Do I advise my patients to do the same? Do I advise my family and friends? And the answer is to all those, yes. But public policy is different. The government is frightened of saying that something is good for us. The marvellous are saying something's bad for us. We've got to stop smoking, A recreational drug just has to be thought to have killed one person and it's banned the next day throughout the nation. But to say something is good for us is something the government does not want to do. So proof, I won't go through these now because these are Hill's criteria. One thing I just want to point out, emphasize, is the gradient of effect. And we've seen that all the time. I'll also look at plausibility. Coherence also spreads from cancer across the other illnesses. Consideration of alternatives. Well, there aren't really any credible alternative explanations for the evidence we've seen. And experimentation we've come on to. Let's look at plausibility. How does vitamin D fit into existing knowledge of cancer? Well, firstly, vitamin D deficiency is not the cause of cancer. What we're looking at this model. Cancer is the result of cause plus susceptibility. It's the same with everything else. Car accidents. We might die because of some major injury. Susceptibility factors come into driving too fast and alcohol. So susceptibility we must look into if we don't understand the cause. And here we're looking at vitamin D deficiency. And I believe as part of that it is immune deficiency. Now we can't ignore the cause, and I think with most of the illnesses and cancers we're dealing with infection. So infection plus vitamin D deficiency is giving us cancer. There are many oncogenic cancer-causing microorganisms: hepatitis B virus, C virus, human papillomavirus, Epstein-Barr virus, Helicobacter pylori, which we've heard about, human T-cell leukemia virus. And there are any number of animal viruses that are inhabiting the houses of many of our population, which we know little about. These 5 are the causes of 60% of all human cancers worldwide. Infection in cancer is important, it's big business. Think about the effects of vitamin D activity. Bone maturation, we're not too worried about today. Immune competence, we are. So let's concentrate for a moment on immune competence. This is the important part of vitamin D. The 3 factors, acute infections, are interrelated. Chronic inflammatory disease, malignant disease. This is what Tim was talking about this morning. And he also put up a list of the organs of the body in which chronic inflammation can lead into cancer. The esophagus in Barrett's esophagus, the stomach, H. pylori, the pancreas in chronic pancreatitis, the liver with the viruses, the colon in ulcerative colitis in particular, the breast, the lung, the skin, bladder, cervix and prostate. In all of these, chronic inflammation can lead into cancer. If we want to prevent the cancers, we've got to somehow deal with the chronic inflammations. Now, the mechanism revolves around the macrophage, the macrophage, the big eater. Again, Tim said this morning, and I was very relieved to see an expert such as Tim using the same expression that I was going to do later. Tumours, wounds that do not heal. Harold Dvorak, professor of pathology from Harvard. One thing we've not had today is a definition of what is cancer. We hear these things: cellular features, mitoses, local invasion, distant spread, metastases. Those are effectively diagnostic criteria in people who've got clinical cancer. But what is far more elusive is what is cancer in terms of the biological understanding of it. And that is something that I've never come across. I think it's a little bit beyond us all. The point is that we're all living with cancer as we sit here, stand here, as we're out at work, as we're at home. Most cancers are developing all the time, but it would appear that most cancers are controlled without the development of clinical disease. What is controlling them? And when the control systems fail, that's when we become ill and die. The great pathologist Virchow in 1863 defined or described the tumour-associated macrophages, TAMs. That observation was lost for more than a century until brought up again by Harold Dvorak fairly recently. And this leads to what's called the macrophage balance hypothesis. This is it. It looks complicated, so we'll run through it a bit slowly. Tissue infection or damage releases cytokines which activate the macrophages, which are derived from monocytes in the blood. And there are two important substances produced by macrophages: tumour necrosis factor alpha, TNF-alpha, and transforming growth factor beta, TGF-beta. And they do different things. The process starts off with TNF-alpha, and then vitamin D comes in and tips the balance towards TGF-beta. Now, TNF-alpha is concerned with continuing inflammation, what is often called autoimmune disease, and also malignant change. We can block TNF-alpha with various drugs. We can suppress continuing inflammation in, for example, Crohn's disease or rheumatoid arthritis, but we don't block the malignant change process in clinical practice. In fact, it may increase it. TGF-beta, on the other hand, is more concerned with healing. So what we've got to do is make sure that the balance shifts towards TGF-beta. And that requires, from my understanding of the story, vitamin D. That's where it comes in. Another effect of vitamin D activity is gene control. And of course, genes are very important in cancer and a variety of other things. We know about this, of course. Not only does this occur in the skin, but it also occurs in plankton entering the food chain and in mushrooms. The liver converts to calcidiol and the kidney to calcitriol. And we've heard, well, I was aware of the macrophage being important, but we hear also that there are other organs which can convert to calcitriol. And calcitriol, vitamin D as calcitriol, activates vitamin D receptors. We've heard a little bit about them. And they're genetically determined complex proteins, and there are many mutations, I hear, 475 I think it was, which give disadvantages. Here we have vitamin D, calcitriol, entering the cell, activating vitamin D receptor, creating a heterodimer, and the next stage is the vitamin D responsive elements in the genome, in the nucleus. This is, again, something that's fairly new to me, but this is where it all happens. So the activation of the genome takes place through the vitamin D responsive elements. And there are vitamin D binding sites known to be associated with almost 3,000 of our genes. We only have 25,000 genes. It's not many. So 10% have vitamin D binding sites. We share 98% of our genes with the orangutan, which might not come as any surprise. Well, probably does come as a surprise. We share almost half our genes with a banana. Well, there aren't all that many genes left to differentiate us from a banana when we're sort of growing from our original seed. The other thing is that we're only actually, as adults, we're only 10% human. You think some people are even less than that, but still. We're composed of 100 trillion cells as we sit here or stand here. And of those, 10 trillion are human cells and 90 trillion are microbial cells. The intestinal microorganisms, a study in, I think it was in Hanover. Now, I only read about this on Monday afternoon when I was coming here. It's in the latest edition of New Scientist, a very good review of this subject. In 124 human subjects, 3.3 million individual different genes have been identified in our intestine. This is mind-blowing. Now, what are they doing? Well, one thing I think is going to be certain, they're not doing nothing. These are going to be associated with something that is important. This is a major source of organisms which can give rise to disease. These have got to be kept in place. And if these are not kept in place, things go wrong. So, is there a vitamin D effect on all these microbial cells in our body? Perhaps there is. We've heard about two of them, well, one of them today, one of them yesterday, that vitamin D seems to keep under control the microbes in our mouth, protecting against dental caries. The vitamin D seems to control the microbes in the vagina. Without vitamin D, abnormal bacteria appear. And we also heard earlier on about with HIV, the PrEP use in uncircumcised men, although I don't think there was any vitamin D relationship to that. But colonic microbes have been associated with the following: diabetes, Crohn's disease, obesity. What it suggested in this New Scientist article is that all these microbes in the colon are actually producing food which we absorb, hence obesity. So you don't have to eat. The microbes are doing it for you. It's a very interesting concept. But the other thing is, what about these colonic microbes and cancer? And that's not yet known. This research is very, very new, but I'm sure it's got a long way to go. Don't forget, we've got a measly 25,000 genes in our human cells, a lot more inside us. Vitamin D binding sites are mentioned 10%, and vitamin D as calcitriol influences directly 226 genes. And these are some of them. Gene enrichment by calcitriol. How is the gene activity amplified? And there are a number of things here. This is from George Eber's work in Oxford. And we've got chronic lymphatic leukemia, just 2 malignant diseases here. CLL, very, very active, very, very responsive to calcitriol, and also colorectal cancer, which we've heard is probably the most related to vitamin D of all the cancers. So how common is vitamin D deficiency if it's so important? And this is looked at in my locality, the patients that I've had with British names, with an average vitamin D level of about 18. Each vertical line is representing individuals. And we have a cut-off at 50% of 18 nanograms per mil. With people with South Asian names, a lot lower. And we there have an average of about 9 nanograms per mil. So 50% of the South Asian people that I see in the hospital are profoundly deficient of vitamin D with blood levels less than 9. These are the people I've had recently with cancers, gastrointestinal cancers. Yes, half of them have low vitamin D below 20. I half expected the levels would be lower than that. But these were people, nearly all, of British origin, ethnicity. This is where I work. This is where we work in the northwest of England, for those who don't know where East Lancashire is, Blackburn is. So we're getting quite a lot of cloud cover. We expect to have low levels of vitamin D. We don't eat much in the way of kippers. If we did, we wouldn't be too concerned, perhaps. If we were eating fish 3 times a day, that's what is required. But otherwise, it's diet supplements. How much? And this is generally what we give. The top one, 2,000, 2,500 units per day, is what is advised. And in the hospital, I prescribe the 20,000 units once a week. The response is good, but it's variable. And Carol pointed this out a few moments ago. We can't predict what it's going to be. There were 3 who went above 100, but that was only to 103 and 105. But we can see a lot are getting above the 40 nanogram line, which is equivalent to 100 nanomoles, but a lot aren't. And there's a great variation in there. The response to intramuscular vitamin D is not at all good. This is 3 months after a standard injection, 300 or 600,000 units. It helps, but not a lot. So I'll briefly finish. We're trying to explain why there is this variation. The first variation, of course, is that people don't take the tablets. We can't, we've got to live with that. But let's just make an assumption that they do. We have the genetics. We have a series of enzymes, each of which is controlled by a gene. And one thing that's fascinated me over the years is that vitamin D and cholesterol have the same precursor. And the more cholesterol that's produced, you could argue, the less 7-DHC there is available for conversion to vitamin D. The next stage, the 25-hydroxylation in the liver, again, under enzyme. The enzyme is under gene control. Polymorphisms of that gene are going to create variation of the enzyme activity. And so it goes on with a vitamin D binding protein, which is important in our blood level measurements. Again, under a gene influence, which may have a polymorphism. I don't know very much about these genes. I just know of their existence. And then, of course, the 1-hydroxylation as well, also under a gene control. And then, of course, there's the inactivation of vitamin D, or inactivation of calcitriol, by the 24-hydroxylase. All these enzyme steps under control of genes with variable effect themselves. And so there's bound to be a variation. So as Carol says, we can't guess what's going to happen when we give vitamin D. We've really got to measure it if we're wanting to get people into the correct range, the ideal range. We shouldn't talk about normal, of course. We should talk about ideal. Now, I would have finished there, but I'm going to quickly mention inhibitors of vitamin D. There are applications in by pharmaceutical companies to produce inhibitors of 24-hydroxylase. What this means is we don't need to go out in the sun, the cynic would say. We don't need to eat fish. We don't need to take vitamin D supplements, which are very cheap. We can take a very, very expensive 24-hydroxylase inhibitor and let that do the job for us. But that is a cynical approach. There is an important role for the inhibitors, as Nico Calais told us earlier on in her delightful presentation. If colon cancers are overexpressing 24-hydroxylase, there's not a lot of point in giving a lot of vitamin D, as it will immediately be inactivated. So the inhibitors of 24-hydroxylase may well become very, very important in controlling and treating cancer. I think that's something I'd not thought about until just before lunch. But there we are. I think that's something else to watch for the future. So there are an awful lot of unanswered questions. I'm sure we're on the right path. We're not quite sure where it's going, but it gets more and more interesting the further we go along. Thank you for your attention.
I just have a short comment. Please don't misunderstand. It would be a very big mistake to inhibit the 24-hydroxylase normally in the kidney. The organism had a or whoever thought that out, it is very important to regulate the 125D3 levels in the serum. But as the speaker David just showed, it might be important to inhibit it locally in the colon, and there would be the challenge how we do it only there.
Thank you. Really enjoyed that. I just want to make one comment as a clinician that from what I've heard today, if I was treating a cancer that was so-called vitamin D resistant, I wouldn't lose any of my enthusiasm for wanting to correct a very low level because of the effect on the stroma, as it were, the immune response and angiogenesis and all the other things. What would you say to that?
Yes, I would go along with that most certainly. Yes, it's a complicated subject, but I think empirically, yeah, I think to push the vitamin D into a high level, yeah, certainly.
I think the European cancer statistics are actually more complex than the way that you present them, and I don't think I think you can easily make a story where you're not presenting necessarily all the data. For example, for breast cancer, the best survival figures in Europe are in Scandinavian countries, which, as we heard, they've got low levels. For breast cancer incidence, it's actually higher levels in social class 1 and 2 rather than social class 4 and 5. Just the mortality is worse because they have access to worse care and they present with more advanced disease. The figures of the breast cancer, I think the mortality will be better in Greece. Greece doesn't have a breast cancer registry, hasn't got a cancer registry. It is not possible to compare cancer mortality in Greece with any other country. They just do not have any figures.
Yeah, I'm not surprised to hear that, and I understand that completely. We have to deal with the figures that we have, and we have to acknowledge that there may be errors in those figures. I agree with you.
You mentioned the important point that the role of cholesterol in the synthesis of vitamin D. And it obviously brings up the question mark of statins. There are a number of increased disease associations with too low cholesterol levels. Do you know if there's been any research in relation to that, the effect of statins in lowering cholesterol and then potentially lowering synthesis of vitamin D?
A high cholesterol has many, many advantages. It's only a disadvantage if you're a relatively young man when there's coronary heart disease about. Now, the epidemic of coronary heart disease is virtually over. The mortality rate 30 years ago was 550 per 100,000. It's now down to less than 10. So the epidemic, so we can forget about coronary heart disease, we can effectively forget about cholesterol. A high cholesterol has many, many health advantages. The beneficial effects of statins are nothing to do with its cholesterol-lowering properties, and I believe that the benefit of statins is related to vitamin D-like activity. I don't know what that activity is, but I wish I did, but I'm sure that's how it's working. Well, anti-inflammatory, yes, but I don't know what part of the inflammatory process statins are working on. I suspect they might be activating vitamin D receptors, I just don't know.
Isn't it true that statins, or certain statins, actually raise serum 25-hydroxy-D?
Yes, that's correct. Yeah.